Welcome to section 3.6. This covers proving theorems about perpendicular lines. Let's jump right in. Theorem 3.8 says that if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Theorem 3.9 states that if two lines are perpendicular, then they intersect to form four right angles. 1, 2, 3, 4. Using these two theorems, is B parallel to A? Because they are both perpendicular to D, then yes, they are parallel. Theorem 3.10 says that if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. The perpendicular transversal theorem, or 3.11, says that if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. Since line J is perpendicular to line H, it is also perpendicular to line K. The lines perpendicular to a transversal theorem, or 3.12, says that in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. M and N are perpendicular to P, so they are both parallel. Distance from a point to a line is the length of the perpendicular segment from the point to the line. It's pretty self-explanatory. This perpendicular segment is the shortest distance between the point and the line. In this example, really? It's not responding. Okay. We'll wait on that. In the example below, the distance between point A and line K is AB. A and K, AB. The distance between two parallel lines is the length of any perpendicular segment joining two lines. The distance between line P and line M is CD or EF. Find the measure of angle 1. What you want to do is subtract 65 from 90 to get 25 degrees. The measure of angle 1 is 25 degrees. Angle 4 and 5 are complementary. Write the theorem that justifies the statement. Theorem 3.10 justifies the statement, which is if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. Find x. X plus 14 plus 63 is 90 degrees. You subtract 63 from 90 to get 27 degrees. Subtract 14 from 27 degrees to get 13 degrees. If you need any more clarification, you can check the textbook or ask Mr. Melms. That is it. I hope you have a good rest of the day.